So actually, this is the longest subtitle that I ever made, and promise I will not do that again, because I'm actually a half tester, half developer, and being that, I learned that the more code you write, the more bugs are in it. So I realized yesterday that there is a bug in the subtitle. It's almost everything. Otherwise, it's okay. Just to set the stage, open source is a great topic, and there are a lot of interesting things are inside. But this talk is not about that you should use open source software, even though that I agree to that. And this talk is also not about how to use open source to make better financing of your enterprise project and also all these things. So it's not about the economics of that. But this talk is about how we can absolutely shamelessly steal some ideas from open source project and just use it in our own normal enterprise projects. So, name is Gaspar Nagy. Most of you know me about SpecFlow. SpecFlow is a BDD product, and it's an open source project. So basically, I was in most of my career, I was also doing a double life. I was managing an open source project, and I was working as an enterprise developer at the same time. So let's just make a quick comparison between these two worlds. Of course, very subjective, but if you think about an open source project, and how many of you have ever contributed to an open source project which is not done by you or by a company, but some fully external contributor? A few of you. Okay, very good. So typically in an open source project, there are random people, right? So you don't have any control of who is actually doing anything on that. While on an enterprise project, typically there are employees and there are some organizational hierarchy, there are bosses whatsoever. In an open source project, typically there is no accountability, so people don't take that kind of responsibility for their stuff, while in a normal project, in an enterprise project, you have employment, there are laws, there are contracts, many other things. Typically, open source projects are super distributed. People don't even know each other's name. Maybe they just know their GitHub ID. While obviously, in a normal company, we are sometimes co-located, even though that distributed is also very common nowadays. In open source project, typically always the communication is asynchronous, so there are no meetings, no time when we are actually together. While in a normal company, we have meetings. Obviously, we also have some asynchronous communication, emails, chat messages, whatever, but we sometimes gather together. In an open source project, typically people are volunteering to do something, if they do or they don't. While in normal projects, you can assign, or somebody can assign tasks, and you can ask people to do something. And also in open source project, obviously there is nothing about no plan about education, so people are just self-learning. While in companies we have coordinated education programs, HR and whatsoever, conferences you are paid for to come, so many other things. So if you see this comparison, and this is what I have also seen, then it looks like that, I mean, the open source seems to be very vague and very weak in terms of that, but still, for me, it was a surprise that many open source projects can provide quality work, and there are many successful open source projects out there, while in our enterprise projects, let's say that achieving quality is not necessarily that easy. In my original version of the slide, I had a much harsh sentence for that, but so for me, that was very surprising. So how can this be possible that with such conditions, open source project can be still successful? And probably there is no single answer, but for me, when I was working on these projects parallel to my normal work, what I have seen that, at least for me, the key was this self-service. And I will tell you what I mean on that. And now, my approach for that will be, or that's what I imagined for this talk, that let's look at how a change is implemented in an open source project, a typical change, a typical pull request in an open source project. And let's see what kind of ideas we could steal from that. And let's see how that compares to the projects that we work on. And maybe you will, through that, you will see what this self-servicing concept would look like. And obviously, then after that, the concept can be applied to many other things as well. So for that, just imagine an open source project. There are quite many kinds of open source projects out there, but let's just imagine something where you are contributing to that project and you are also using that project. You are testers, so let's imagine that there is a testing tool that you are using, but sometimes also helping that project. And on the other hand, let's compare it with your normal project where you are building up some components, some features, and those components and features are used by you or by your colleagues, by the other teams, and you are also using the components and features that the other teams have developed. So that's kind of the parallel, two parallel world that we can combine. So as I said, as an example, I would like to use how a change is implemented in an open source project. And typically, changes are implemented in open source projects with a pull request. How many of you have ever made a pull request? Many of you, very good. So probably you are generally aware of the pull request definition in general. I was just taking some quotes from the different sites. So GitHub mentions, among many other things, that pull request is a proposed change. In Atlassian, you can say that this is a kind of mechanism for the developer to notify the other team members that you have completed something, completed a feature. So it's a kind of notification or a proposed change. In simple words, we can maybe say that basically pull request is a feature of GitHub or the other tools that is supporting the integration of independent changes with the main development line. So it's a feature. But if you look at how open source projects use pull request, then what is visible that this has slowly changed from being a feature to a process. Okay? And this is very important, and this is what I would like to focus on today. And this process, even though that the majority of the pull requests are done by developers, it has many quality-related aspects, so it makes sense to look at that even as a tester. So we said that pull request is a feature for integration. So what is integration? That's also a very interesting topic. There's just a very simple slide that is summarizing that. Basically, I'm doing something myself while the others are also doing something else. And at some point, we have to merge the things that we have done, and there might be some potential conflict. That's the integration that we would like to provide some support for. And the pull request is a feature to support that. Probably many of you generally know how pull requests work. It's just one single slide. Let's imagine that there is a main line, the development line, a trunk or main, doesn't matter how you call it, and you are working on your own branch. And at some point, you think that you are ready, and at that point, you can open a pull request. That's the word that has been developed. And when you are opening the pull request, what basically happens in the background, what basically happens at GitHub, that it creates a temporary branch for you, and basically it merges the thing that you did with the thing that the others were doing so far, and it just runs all the quality gates, typically the CI build for that, so it sends some sort of verification, and it turns out whether there is a conflict or not, and if there is a conflict, there is some problems to fix, then obviously you can do a fix, and you can just redo the same thing, and finally it just becomes successful, and at that point you can choose to merge this thing into the main line, and then basically this successful result is going to be the new element on the main. So that's how you can see this as a feature. But as I said, for us, maybe it's even more important how that looks like as a process. For that, I will build up a similar diagram that you have seen, so there will be two lines there, and at the end it will be quite crowded, because you will see that there are quite many steps are actually happening while that. Sorry for the crowded diagram, but hopefully it will be somewhat useful for you at the end. So, how the thing starts. So you are an open source contributor, and you are doing voluntary things. So typically what the thing starts in a way that you have an idea. I think I can make this better, right? So that's how the things start. And when you do that, what you typically do in an open source project that you haven't worked with that, you are just opening up GitHub and check the contribution guide. Practically nowadays, all of the open source projects have a contribution guide, which is very, very useful because with that, basically you can set up your local environment and start doing some meaningful thing. So that's already the first idea that we can steal. So having a contribution guide, that sounds like a very simple concept, but it's super useful. And if you look at contribution guides on GitHub, then you will see that these are typically an all-in-one document. So it's a simple one-page thing that is helping you to get up to the speed as quickly as possible. And they are always called the same. It's always easy to find it. And it contains how to set up your local environment. But many of the open source projects also have some guidance of how to run your tests. And that's also very important for someone who is maybe contributing to the test parts of that. OK, so that's how we are. We have a local environment. And we can start working. I start work on the idea. It's really just the first steps of that. And after a couple of changes, I somehow feel that the solution gets shaped. And what that means is that it's absolutely not ready. Even locally, maybe some of the tests are failing. But I already feel that, OK, I already have a concept how I'm going to solve that. And at this point, I can already use the idea of this pull request feature because I can open a draft pull request. A draft pull request is basically just a pull request without telling anyone else that please don't look at this yet, but it's verifying it for myself, self-servicing, right? So you can open a draft pull request, and that can verify how you are with the other parts of the code. And obviously, you know that it will fail because it's easy. It was even failing locally. But by seeing how it fails and what is not failing, maybe, you can learn a lot. Okay, so that's I think that's the most important idea, at least from the process point of view of pull requests, so that they are encouraging early validation, early verification of the stuff. And by having that, basically people will also encourage to do smaller steps. And obviously, with smaller steps, it's much less risky at the end. So that's very good. And typically in GitHub, you don't really have to do anything. You don't have to go to the department who is making new branches. You don't have to go to the department who is making new pipelines and whatever. It just works. And it's using your pipeline system that you anyway have for the product. Of course, you can customize it if you want, but by default, it just works. Okay? So that's great. We have an early validation. And based on that, and based on our concept that we want, obviously, we are making further changes and improvements. And pull requests will always keep validating the things for me, keep verifying whether we are fine with those things or not. And probably at some point, we start to feel that what we have done is a kind of good enough. And this good enough is a very important thing. So you hear in conferences like that everyone should contribute to the quality. And you probably have seen that this is not that easy always. And of course, there are many reasons for that. But I think one of the reasons why people don't necessarily can contribute to quality, especially developers or some other roles, is that they don't have a feeling what good enough is, or what is quality. What does it mean that what I have done is good? Okay? And we, as testers, have to help them to do this self-servicing. So what the pull requests are, or what the open source project do for that, they are just doing simple checklists. So whenever I'm opening a pull request, there is a bunch of questions that is basically the purpose of those questions is just to remind me that, did you think about documentation? Do you think that this is a bug fix, or it's a new feature, or maybe it's just a refactoring, or all these questions? And basically, without any effort, it guides everyone who would like to contribute to the project to think it over, what kind of thing they are missing, what kind of quality aspects they still need to focus on, and what is the kind of change that they are doing. So again, another simple but very, very good idea to do that. The other thing that I think it's also a good idea to steal is that pull requests are verifying the things in integration. So this means that it's not like running the build on that local branch isolated from the other, but it's always merging it with the main thing. So even if you are running the pull request build 2 times after each other, you can have different results at the end because maybe somebody has changed the things on the main line. So changing or verifying the things in integration, that's also something that we should keep in mind, and it's also providing us a lot of help. Okay, so we said that we feel like it's good enough. Everything is bright and shiny on the pull request as well. That's probably the point where I can say that, okay, I think now I'm good. Please, others, have a look and check that. So other contributors can do some review, and of course, based on the review, you can make some comments. I was using for this review part a different color, maybe not the nicest, because actually, from this process, that was the first time when someone else had to involve. So until that point, everything was self-service, so you had a lot of guidance of how to make quality work, and that's the first time when someone else needs to come and check your code. And actually, even that is done in a very useful way, because it's typically an asynchronous code review. So that means that there is no code review meeting. I mean, if you have been in such situation, typically it is done for developers, then you know that this can be very inconvenient, so that people are not necessarily good in taking frontal criticism, and also not so easy to give this criticism frontally. But if it's done asynchronously, the things are much easier, and altogether many of the problems could be better managed. Okay, review has done. We applied the comments, so then obviously the build process is always running, and we always get an indication whether it's good. And everyone who was involved can maybe do an approval. If you want to have it like that, typically open source projects do that, and then the change gets merged, and this is how it finally gets into the open source product. So that was the pull request, and as you have seen, I mean, there are a couple of other things that happen in an open source project, how they are managing bug request or build process and many other things. But always the key is that try to provide some help for the people to get to the quality themselves, and not directly guiding them or micromanaging them to provide the quality. So at least through this pull request, these were the ideas that we could steal. There are a couple of others as well, and if you find me in the conference, maybe during the lunch break, I'm happy to tell about a few others as well. But probably that was enough, or that was useful to see what is the kind of mentality that the open source project has typically differently, or working differently than our projects, and that would be also very useful for us. So to summarize this, basically, we can learn that in open source projects, the verification is more replaced by feedback. Of course, these are not exclusive things, but providing more efforts to provide the feedback for the one who is working is probably more efficient than just providing the verification result. Instead of avoiding conflicts and try to work as long as you are as possible alone, and only at the end trying to see how that works together, open source projects are encouraging conflict by this early validation and through the pull request concept, and also. We haven't really touched the release process of typically of these projects, but instead of trying to roll back if something is wrong, all this process is encouraging them to roll forward, so that if your pull request has some problem, no problem. That's anyway an isolated change. We can provide you feedback, and you can improve that afterwards. And I think that puts a lot of responsibility for us as testers, because basically we have to be the ones that are enabling this self-service feedback concept for the entire team. So, stupid analogy, but instead of providing them the testing as fishes, we rather should teach them how they can do this themselves, and how they can verify their own code and provide a more quality or better quality result. That was for me. Thank you very much.
A huge thank you from our side as well. So far, 3 questions for you. The first one with most likes is there something from enterprise development that should be more in open source development?
Obviously, there are plenty, but probably the more important is the money. Okay, so if you want, give some money to the open source project. There are plenty of opportunities for that. They need that. That's how I can say.
Okay, what happens in an open source project when 2 or more developer creates the same new features? Isn't that a problem?
I don't think so. Theoretically, obviously, it could happen. I have never seen it. So if that would happen, probably they would realize. So people are just tracking each other's pull requests as well, because looking at someone else's pull request is also a very good way to learn about the culture of the product or the project, how the others are making changes, how the others are testing their stuff, and it would very quickly show up that actually 2 of you are working on the same thing. But of course, in some projects, there are some, you can also open a discussion before you actually start working on a feature. You can open also a discussion and ask with the others whether they would be, whether they have any idea or any suggestions to move on with that feature.
Okay. How to encourage people to create pull requests as soon as possible? Is it okay to force early code reviews all the time?
That's a very good question. I don't know the answer, but what I have observed that if you are, first of all, teaching them that it's absolutely safe. So teaching them that making a draft pull request you can do anytime. Nobody will look at that. Nobody will, whatever, criticize you. It's an absolutely safe thing to do. And you just provide them the necessary infrastructure to be able to do that as easily as possible, then people will pick it up. And it just happens automatically. So that's my suggestion is, so make a culture where you can safely do for example, a draft pull request, and teach them how good this is as a validation method, and then the thing will work automatically.
Okay, how to handle pull request comments gracefully if you don't agree with the suggestions given?
Very good. Obviously, this is where in the individual's personality comes in. Obviously, there are people who can better comment those things, and there are people who are a little bit more harsh. But one thing that I have done as a mistake, and that I have learned, that if you don't agree with that, then you should rather say no in some way. In the earlier ages or years of SpecFlow, I have approved a couple of pull requests that I'm still regretting, and it's very hard to get rid of those. Because the people who were suggesting them were super enthusiastic, and actually the feature itself, technically, it's working. It's just solving a problem that doesn't exist, and we have to keep maintaining it afterwards. So feel free to say no, and you have heard a couple of other presentations about that. That maybe you can make a suggestion so that, yeah, this is a great thing, but we don't see a good usage of that. But instead of that, would you be interested to do rather that one? That's maybe a way to help people.
Are the requirements documented for an open source project, and how are they managed through development life cycle?
You are asking the wrong guy, because I'm generally a BDD evangelist or something like that. I call myself a BDD addict. And the benefit of BDD is that the tests themselves are working as a specification. So if you are doing your tests as we wish in that project with BDD, then basically the BDD scenarios are going to be there, and they will provide you some way of requirement documentation. Of course, we could have other kind of documentation, but having a documentation that is never up to date is probably worse than having a little bit less documentation, but that one is automatically validated. So yeah,